Hello everyone, my name is Ubaid Shah, and in this video we will dive into the world of machine learning. To be specific, in this video we will discuss about the fundamentals of linear regression. So we will discuss what exactly linear regression is and how and why it is crucial in the world of machine learning. So let's get started. So suppose if we are having a data set like this, okay, so where we are having values of x and y, okay, so x is equal to 1, 2, 4, 3, 2, and when the value of x is 1, then the value of y will be 1. When the value of x is 2, then the value of y is 1.9. Then for 4 it is 3.9, for 3 it is 3.1, for 2 it is 2.1, okay, and we need to find out the value of y when value of x is 5, okay. Now from here you can understand that there is a relationship between y and x. So in case of machine learning, whenever we got the historical data, we find the relationship between the dependent variables and the independent variables, okay. So in this case over here, y is called as a dependent variable, and it is also referred as a label or target, whereas x is called as independent variable, also called as features, okay. Now the value of y depends on the value of x. So in case of machine learning, we form the relationship between y and x. So this relationship will be y is equal to f of x. So y is the function of x, okay. Now suppose we are forming the relationship between the y and the x graphically like this. So this is the y axis and this one is the x axis. So when the value of x is 1, 2, 3, 4 and 5, we got the values of y's, okay. So y is equal to 1, 2, 3, 4 and 5. So when the value is 1, this is 1. If it is 2, then it is 1.9. When it is 4, then it is around 3.9. When it is 3, then it is 3.1, okay. When it is 2, then it is 2.1. Now we need to find out the value of y when the value of x is 5, okay. So in case of linear regression, we first draw a straight line out of these points, okay. So these points are called data points, and we are trying to find out the close relationship between the x and y by drawing a best fit line, okay. So in case of linear regression, we need to find out the best fit line. So suppose if we join this one point over here and second is this point, okay. So this is the line for these data points, okay. Now there will be a relationship between y and x like this. Y is equal to mx plus c, okay. So where you can see the c will be intercept point, okay, and m is the slope, okay. Now what is intercept and what is slope? So when we extend this line like this, so wherever this line intersect the y axis, this point is called the intercept point, and the angle of that particular line is called as the slope. Okay, so slope represents the strength of relationship between dependent and the independent variable. So we can say that between y and x. Okay, and intercept represents the intersection point of line on the y axis. Okay, now suppose if we are having a data set like this, where we are having multiple independent variables x1, x2, x3 and x4. Okay, and we are having one dependent variable y. That time this equation can be modified as y is equal to m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 plus c, where m1, m2, m3 and m4 are called as slope coefficients and c is the intercept. Okay, now this equation can be modified as y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus beta 4 x4. Okay, now where the beta 1, beta 2, beta 3, beta 4 are called the slope coefficients and beta naught is the intercept. Okay, this is the equation of hyperplane. Okay, so whenever we are having so many dimensions, that time it will form a hyperplane. Okay, but in this case we are assuming that there should be a linear relationship between the independent variables and the dependent variables, irrespective of the count of the independent variables. Okay, now in case of linear regression, so we are having dependent variable y and the independent variable x. So the nature of y will always be continuous numerical in nature, continuous numerical. Okay, whereas the nature of y would be categorical or discrete or continuous. Okay, but the nature of y will always be continuous in nature. If it is categorical, then it will be a problem of the classification. Okay, so now let's discuss the applications. So in which scenario we are going to use? So suppose if we want to predict the prices of the house in the real estate market, that time we can use the linear regression. So price of houses, okay, or the prices of the cars or prices of any goods. Okay, so if we are having the historical data of that particular goods or cars or the houses, that time we can use the linear regression. Then if you want to predict the salary of a particular person based upon its qualification, age, gender, okay, so that time we can use linear regression. Then if you want to forecast the business values, like if you want to forecast the sales, okay, based upon some scenarios, then we can also use linear regression at that time. Okay, so these are the application in the real world scenario, and we can use the linear regression if and only if there is a linear relationship between independent variable and the dependent variable. Okay, so I hope you have understood the fundamentals of linear regression. So this is very basic understanding about the linear regression. It is a very vast topic, so for that we will meet in the next video. Okay, until then, stay curious. Bye.